Yes, students. Already we have the discussion about the manufacturing of sulfuric acid. It means we are forming the sulfur trioxide there. And to obtain sulfur trioxide, first point is we have to obtain sulfur dioxide. Second point is sulfur dioxide we convert to sulfur trioxide. And third point is sulfur trioxide we convert to concentrated sulfuric acid. These 3 points, 3 stages are involved in the contact process for the manufacture of sulfuric acid. How can we obtain sulfur dioxide? Two methods: a direct combustion of the sulfur to get the sulfur dioxide, and other compound of sulfur. Here is a mistake. Ferrous sulfide you can consider. Last time I had given the proper reaction. You can go through that reaction. Here the reaction balancing is what the issue. But what is important? Ferrous sulfide will form the sulfur dioxide. This is the other way of producing the sulfur dioxide. Now next point is conversion of sulfur dioxide to sulfur trioxide via the combustion, via the reaction with oxygen. Let me see who wants to enter. Ganesh. The flow chart or the scheme, if you see the first point, sulfur dioxide, we are reacting with the oxygen or the air in the ratio 1:1. If you see the reaction says that for 2 sulfur dioxide, we need 1 oxygen to produce 2 molecules of sulfur trioxide. So from first instance, one will think if you take 2 molecules of SO2 and 1 molecule of O2, or if that proportion remains as 2:1, then there should be the good result of sulfur trioxide. It remains first instance expectation. Yes, students, are you following what is my expectation?
Yes, sir.
Yes or no?
Yes, sir.
Okay. But here see what is the ratio? 1:1. It is a practical aspect. This aspect is a practical aspect, and whatever here is the reaction is a theoretical aspect. Now how these practical aspects are related? Now focus or the pay attention towards this reaction. Here number of gaseous molecules left side are more. How many are there total gaseous molecules? 3, and it is resulting to later on 2 gaseous molecules. So number of gaseous molecules are decreasing. So the course of the reaction itself is decreasing the number of molecule. Number of molecule will decrease, so volume will shrink. Volume will decrease. Means it indirectly, like by increasing pressure, how we decrease the volume, likewise it happened here automatically in this reaction. 3 molecules are converted to 2. Quantity is less, volume is less, automatic less volume is there. Volume is less means pressure is more. So it says that this reaction, if I have to perform, if I want to proceed it to right hand side, forward reaction, if I want to more extend, then what should be there? General expectation remains pressure should be high. Then only I'll get sufficient or proper quantity of sulfur trioxide. It is a one expectation. More number of reactants if they are, then more number of the products will be there. So as per theoretical point of view, there should be 2:1, but practical point of view, volume is 1:1. Any reactant if increases, the reaction will proceed to the high level. But here important point is catalyst. Role of the catalyst, functioning of the catalyst, working of this catalyst. What catalyst does? Catalyst gives the provision to combine one with what the other. Too many reactants came, then combination will be the high. It is not likewise. Catalyst also needs some time for the combination. So practically people found when we take 1:1 ratio for reactant, then there is a considerable production. More production we want, and therefore they have considered here 1:1 volume for sulfur dioxide and oxygen. Students, are you getting partly this concept at least?
Yes, sir. Yes, sir.
Yes. Okay. Now see, second condition. Reaction is performed at which temperature? 400 to 450 degrees Celsius. Last time we have discussed, if reaction is exothermic, means during the course of reaction, heat is evolved, and by any means, surrounding absorbs the heat, surrounding takes the heat, then reaction will proceed to forward direction. Production will be there, product formation will be there. If we see that reaction of sulfur dioxide to obtain SO3, that reaction is exothermic or endothermic? Yes, this reaction exothermic or endothermic?
Exothermic.
Exactly, exothermic. See here, delta H is equal to minus 196 kilojoule per mole. Minus sign of delta H means heat is evolved. It is exothermic reaction. During the course of reaction, heat is evolving. So what is our expectation? Cooling should be there, as was there in the manufacture of ammonia. But here, what is the situation? We are performing this reaction at what temperature? 400 to 500 degrees Celsius. At that temperature, we are performing the reaction. From first instance, we feel it is a high temperature. See, high and low is a relative thing. For this reaction, if we obtain that temperature, then production means people have worked with all factors: temperature factor they have considered, concentration factor they have considered, pressure factor they have considered, catalyst factor they have considered, and they come to conclusion that if the temperature remains 400 to 450 degrees Celsius, then reaction proceeds to more extent, or reaction gives the good quality or good production. Therefore, we are maintaining 400 to 450 degrees Celsius. So, what are the concept I told to you? If exothermic reaction, the heat is to absorb. Yes, certainly it is. Only spontaneity is not important. Only getting SO3 is not important. Proper reaction is important. As like only completion of syllabus is not important. Your understanding is important. Your reaction is important. Your mingling is important. Proper equilibrium obtaining is important. So only shifting to the end is not fair practically. We are talking here about the practical point of view. Practically, in order to get the spontaneous formation of SO3, we need to maintain 400. So we need to maintain low temperature. But when we perform the reaction at 1 to 2 atmospheric pressure, or catalyst vanadium pentoxide, at that time temperature condition 400 to 450 degrees Celsius is to use. Okay, I'll come to that point again. About the pressure, what reaction is? SO2 plus O2 giving SO3. Here number of reactants are more. 2 SO2 were there, 1 O2 was there, and 2 SO3 were there. Number of reactants are more, number of product is less, volume of product is less. So indirectly pressure is there in the reaction. If we develop more pressure, then it will be easy to obtain the SO3. But here 1 to 2 atmospheric pressure is not less. It is also considerably more for this reaction. It is true, high pressure should be there, and it is there, 1 to 2 atmospheric pressure. So only don't go on the number. At 1 to 2 atmospheric pressure is sufficient for this reaction. And the catalyst which is recommended is V2O5 for the combination between SO2 and SO3. And that results a sulfur trioxide. And the sulfur trioxide later on gives what? The H2SO4. How it is obtained, that I discuss one by one. Now see, let us understand the conditions. Up to here, I am asking to you, is it clear what I discuss? I am discussing it again.
Yes, sir.
Okay, good. Now see, for first step is a conversion of sulfur dioxide to SO3. First step is SO2 formation. Second stage, SO3 formation. Third stage, now I'm talking about, that's a sulfur trioxide to sulfuric acid. What one will think? SO3. If I want to obtain H2SO4, yes, help me. What shall I do? Yes, what shall I do here?
H2,
I could not hear
H2O.
you. Please loudly.
Addition of H2O.
Yes, addition of H2O. We will get it. It is a first instance, means SO3 gas. If you pass through the water, then you will get the H2SO4. Yes, it is true. But the yield that we get is not a satisfactory, or it's very difficult to handle that reaction. Exothermic reaction it is. And therefore, though whatever the conclusion you have sought out, simple combination, it is not followed. It is mentioned, see, this can't be done by simply adding water to sulfur trioxide. Why? The reaction is so uncontrollable that it creates a fog of sulfuric acid. Means exothermic reaction, and in atmosphere also, so too much sulfuric acid will not come out. It is a very dangerous reaction. and therefore this reaction is not recommended. Instead of that, what we are doing, sulfur trioxide is first dissolved in concentrated sulfuric acid. Interesting thing, we are discussing the formation of sulfuric acid, and what we are doing, we are passing this sulfur trioxide in sulfuric acid. Means already we should be with the sulfuric acid, so that sulfuric acid helps to prepare new sulfuric acid, additional sulfuric acid. So what is the reaction? Sulfuric acid reacts with sulfur trioxide to produce oleum, H2S2O7, fuming sulfuric acid. The oleum, it is called as fuming sulfuric acid. Now afterwards see, this fuming sulfuric acid can be reacted safely with water. Rather than combining SO3 with water, we are reacting fuming sulfuric acid or oleum with the water to produce sulfuric acid twice as much as you originally used to make the fuming sulfuric acid. Now, why I am saying twice? See, during the course of reaction, here only one oleum molecule is obtained, only one fuming sulfuric acid is obtained. That one oleum molecule will react with one water molecule to produce, important thing here, see, how many H2SO4? 2 H2SO4. So what is the chemics in the reaction? We have used a 1 H2SO4 at the beginning and we are getting 2 H2SO4 at last. Anyhow, H2SO4 is added. So again, that same H2SO4, part of that you can use, part of this H2SO4 you can use to combine with SO3 to produce H2S2O and H2S2O and react with water to produce H2SO4. So one via media is there, via reaction is there. What is that reaction? In spite of combining the sulfur trioxide directly with the water, as you rightly answered, what is going to happen there? We are combining oleum, H2S2O7, with water. Is this point clear to you?
Yes, sir.
Waiting for replies from other. If not clear, then say no. I will explain again. No, students, I want your replies.
Sir, please explain again.
Okay, no problem, no problem. I explained. Now listen carefully. Sulfuric acid. First step, we have to obtain sulfur dioxide. Second step, we have to obtain sulfur trioxide. Third step, we have to obtain sulfuric acid. Are these three steps clear?
Yes, sir.
How to obtain sulfur dioxide? Two ways are there. Two methods are there. First method, direct combustion. Second method, from compound of sulfur, maybe iron pyrite or FeS, which will react with water to produce sulfur dioxide. You can go through the reaction later on. Is it possible to understand that reaction?
Yes, sir.
Okay. If not clear, then you can work again for that. Those for whom it is not clear, no, they can work. And if further not clear, you cannot ask me. Now this sulfur dioxide, we want to convert to sulfur dioxide. How? By combination with oxygen. It is exothermic reaction. It is understanding of that. So read this reaction again. What is going to happen in this reaction? Just wait. I remove these other things. Read this reaction. What is going to happen in this reaction? Two molecules of sulfur dioxide, one molecule of oxygen. They are forming two. So in reactant side, answer for my question, how many molecules are there?
3,
Three. In product side, how many molecules are there?
2.
Two. So there is decrease in volume, decrease in V, means pressure is more. So if I have to perform this reaction, so my first expectation, this reaction should be performed at high pressure. First instance, my conclusion. Is it clear?
Yes, sir. Yes, sir.
Yes. But which high pressure we are choosing? That high pressure means 1 to 2 atmosphere sufficient. It is sufficiently high for this reaction is the first point. Second point, if you see this reaction, if you have answered that already, delta H value is negative. It means this reaction is exothermic. If reaction is exothermic, then that reaction to be performed at low temperature. But which temperature we are using? We are using 400 to 450 degrees Celsius. Then you will take doubt, is that low temperature? Yes, for that reaction it is low temperature. Just wait. For that reaction it is low. Reaction can properly execute at that temperature. It is the second condition, that is what of the temperature, and the catalyst is the V2O5. About the volume, what one will think? One will think that two molecules of SO2 and one molecule of O2 should react. So their ratio should be 2 is to 1. But what is the reality? Reality is ratio is 1 is to 1. Means ideally what situation is there, it is not in reality, it is not in practice. People have worked a lot. They have changed the volumes of SO2 and O2, their ratio, their proportion they have changed. They have varied the pressure, they have varied the temperature, they have changed the catalyst, and at last they come to know, they concluded this 1 is to 1 volume of reactant is enough. Temperature 400 to 450 enough. 1 to 2 atmospheric pressure enough. Catalyst V2O5 is suitable to get sulfur trioxide. Up to here, concept clear?
Yes, sir.
Okay. Further detailed explanation I am giving. Just wait. After obtaining sulfur trioxide, next step is getting sulfuric acid. How we get sulfuric acid? For that, you said that it may be the course of the reaction that sulfur dioxide combines with water to produce H2SO4. But this is not the practical way to perform the reaction. Why it is not the practical way? Because simply adding the water to sulfur trioxide, the reaction is uncontrollable. Fog of sulfuric acid will be obtained. Therefore, it is not recommended. Then what to do? Solution is sulfuric acid you have to combine with sulfur trioxide. Means to obtain sulfuric acid, add sulfur trioxide and sulfuric acid. What will be the result? Result will be oleum. It is called fuming sulfuric acid. H2S2O7. Later on, this oleum will react with water. We have to add little water and we will get H2SO4. So what you were doing? You were adding H water in SO3, but now you are going to add water in H2S2O7. Why? Addition of water in H2S2O7 is simple, is safe, is easy rather than adding water in SO3 or passing SO3 in the water. So safety is considered here. Anyhow, what we are getting? We are using one molecule of the H2SO4 and we are getting two molecules of H2SO4. So gain is there. So production is there. But the way is via formation of oleum. Up to your concept clear?
Yes, sir.
Okay. Now see, the one by one I'm discussing the reaction conditions about which we have to discuss. Already I had discussed that, but now one by one, stepwise we will see what is the proportion of sulfur dioxide and oxygen. Is what we are discussing. Now answer for my question. Theoretically, ideally, what should be proportion? Yes, help me.
2:1.
3:2.
No, 2 is to 1. See the reaction. Here, see at the bottom, reaction is there. 2 sulfur dioxide molecules and only 1 oxygen. So expectation was 2 is to 1. But what is the reality? What is the practice?
1
Practice is 1 is to 1. Why? That we are discussing. See here. Sulfur dioxide and oxygen mixture going into the reactor is in equal proportion by volume. It is a statement. One by one, see. What Avogadro's law says, equal volumes of gases at the same temperature and pressure contain equal number of molecules. That means the gases are going into reactor in the ratio of 1 molecule of sulfur dioxide and 1 molecule of oxygen. Proportion is 1 is to 1, no? As per reaction, it should be 2 is to 1. But here in practice, it is 1 is to 1. What is the reason? Reason that we are discussing. Why are we not using 2 is to 1? See the reason. Excess of oxygen relative to the proportions demanded by the equation. Means what we are doing? We are adding excess of oxygen relative to the proportion. Now, why it is so? It is as per Le-Chatler principle. First, understand whether excess of oxygen. When we consider 2 is to 1, means 2 liter of SO2, 1 liter of oxygen. So what is the proportion of oxygen? How much extent in complete vessel? So in reaction mixture, it is only 33% about. Oxygen is 33% ideally. Practically what we are doing? We are using practically 1 is to 1. 1 liter SO2 and 1 liter O2. Answer for my question. What's the proportion of oxygen here? What is the proportion? 1 is to 1 means what is the proportion of oxygen? Is my question clear?
1:2.
Yes, 1 is to 1 means in terms of percentage, what is the proportion? What is the amount?
50%.
Yes, it is the 50%. Ideally, it should be 33%. Practically, we are using 50%. Means practically we are increasing the concentration of sulfuric acid. Sorry. proportion concentration of oxygen, due to which what happen, as per Le-Chatler principle, reaction causes the position of equilibrium to shift towards right. What is Le-Chatler principle? If you disturb the equilibrium, equilibrium adjusts in such a way, changes will be nullified. So if concentration will be increased to left side, then reaction will be to forward direction. So amount of sulfur trioxide which will get obtained, that will be the more if we use 1:1 proportion. Then one will say, why 1:1? Then increase 1:2. Take more oxygen. No, there is one limit for excess also. If too much excess, then on catalyst only oxygen will blow. Therefore, it should be in control. It should be in limit. See here, since oxygen comes from the air, this is very cheap way to increase the conversion of sulfur dioxide into sulfur trioxide. Means when we take a more proportion of oxygen, economically it is suitable or it is convenient. Cheaply oxygen is what available. Then one may ask a question, if cheaply available, then why not to use even higher proportion of oxygen? That question I asked to you. Why 50%? Use 75%, use 90% of oxygen. No, this is easy to see if you take an extreme case. Suppose if you have a million molecules of oxygen to a every molecule of sulfur dioxide, equilibrium is going to tip very strongly towards sulfur trioxide. Ideally, sulfur trioxide should fastly form, simultaneously form. Every molecule of sulfur dioxide will be converted to sulfur trioxide virtually, ideally. Great thing. But pay attention. But we are not going to produce sulfur trioxide every day. The vast majority means every day in the sense what? Spontaneity is not our important. It is important. By the way, equilibrium also is important. Production also is important. So how can we improve that our production? See here. What we are passing over the catalyst is oxygen, which has nothing to react. If more oxygen is there, oxygen has to react. No, spontaneity point of view it is right, but practicability point of view, equilibrium maintenance point of view, it is not fair. So sufficient SO2 should be there. So after thorough research, thorough work, people come to know only as an haphazard increase in the concentration of O2 is not fair, not good. By increasing the proportion of oxygen, we can increase percentage of sulfur dioxide converted, but the same time decrease the total amount of sulfur dioxide made each day. This reaction will fast, but more production will not be there. Therefore, the mixture 1:1 turns out to give you the best possible overall yield of sulfur trioxide. Here is a explanation for the use of reactants in the proportion 1:1. Students, is it clear now or it is bouncing?
Clear, sir.
Okay, only one reply I'm getting. Please talk loudly.
Clear, sir.
Okay,
Yes,
good.
sir.
Yes,
Good,
sir.
good, good. Very good, very good. Now come to next point. Next point is temperature. We need to shift the equilibrium position as far as possible to right side. Why for? To produce maximum amount of sulfur trioxide, which is the product, so that later on we will get the more sulfuric acid. It is our ambition. It is our intention. Now forward reaction is what? Forward reaction is the production of this one, sulfur trioxide. Again, use of Le-Chatler principle. See, equilibrium, how is important. As per Le-Chatler principle, this will be favored if we decrease the temperature, if we maintain the low temperature. The system will respond by moving the position of the equilibrium to counteract this, and in other words, by producing more heat. System will produce more heat because here delta H value is negative. Reactions producing more heat to absorb that. Low temperature condition, cool temperature condition are ideally expected. But see here, in order to get such as much sulfur dioxide as possible in the equilibrium mixture, we need to lower the temperature as possible. And the question that the author has asked, 400 to 450 degrees centigrade. See, is it not a low temperature? Low and high we consider in terms of our perspective. Ice means cold, it's a low temperature. Who said ice is a low temperature? It can also be the high because ammonia liquefaction, carbon dioxide solidification, or nitrogen liquefaction. Too low temperature is necessary. So low and high is a relative concept. So don't be in a position to understand temperature means room temperature means average. So to 400 to 450 degrees centigrade for this industrial chemistry also is a low temperature. Practically people have worked on this, and therefore it is said because sink means where temperature is absorbed. It also is a economically expensive way because coolant are necessary. Means one example I give it to for your understanding. At F5 level, you might have prepared the solids, and for cooling you might have kept in the ice bath. What is the role of ice bath? Ice can cool early. Cooling will be the early. You want to attain the low temperature. Means room temperature is sufficient for you time being. So ice can cool it fastly. But to prepare ice, cryogenic engine means fridge at least is necessary. Cooling, some investment is there for that. In industry, just for cooling, more investment is necessary. And other way, simply keep for little more time or keep under the tap water. The solution will get cooled. So as like we see the affordability in industry is a main concern. Absurdity is right. If we make a low temperature, then reaction will move more to the forward direction. More yield will be there. More spontaneity towards the forward side we can find. But only getting spontaneous SO3 is not important. Practical affordability also is important. Even if maintaining 400 to 450, 400 to 450 degrees centigrade, that temperature is not maintained by heating. It is automatically obtained because reaction is producing heat. Reaction produces more heat. Then we decrease that heat by cooling. Cooling we are doing to less extent, not to the more extent. So our cost concern of cooling we are decreasing. If we do not cool, then reaction temperature can go more than 1000 degrees Celsius because exothermic reactivity is there. If it goes more than 1000 degrees centigrade, then the rate of reaction will decrease. So after a thorough work, people come to conclusion, we have to work for cooling. We have to decrease the temperature, but decrease the temperature in such a way the temperature will be 400 to 450 degrees centigrade. It is enough. Economically also it is suitable, affordable. Students, are you getting this point?
Yes, sir.
Only one replied could note.
Yes, sir.
Okay, further one reply at least. Okay, if not clear, then say not clear. I will discuss, but I want answer. Yes, Pratiksha, Alia, Vaishnavi, Rupashri, and Kartika. What's your reply?
Clear, sir. Sir replied.
Okay, you have replied.
Clear.
Vaishnavi, Rupashri, Alia.
Yes, sir.
Replied,
Okay.
sir.
Vaishnavi,
Yes, sir.
Ganesh has replied. Vaishnavi, what's your reply?
Yes, sir.
Okay, then when I was asking your reply, now I came here on the presentation screen and I'm asking to you. So please reply when I ask the question. Okay, fine. So about temperature, even if not clear, here is a chance for you to understand. Lower the temperature we use, slower the reaction becomes. It is general point of view. General, low temperature, low reaction. A manufacturer is trying to produce as much sulfur trioxide as possible per day. It makes no sense to try to achieve an equilibrium mixture which contains a very high proportion of sulfur trioxide if it takes several years for the reaction to reach that equilibrium. So only saying that low temperature or high temperature, general point of view, we could not think. How much time it takes to attain that equilibrium is important. By maintaining the temperature of 400 to 450 degrees Celsius, the reaction somewhat get boosted. So equilibrium gets attained easily. Only obtaining forward, only getting sulfur trioxide is not important for us. We want a efficient equilibrium. For that, this 400 to 450 temperature is what considered. Now pay attention again. The gases to reach equilibrium within a very short time that they will be in contact with the catalyst or the reactor. So as soon as they come in the contact with the reactor or the reactor comes in the contact with the catalyst, we want there should be the product formation. So what is the compromise say? The 400 to 450 degrees centigrade is a compromise temperature producing a fairly high proportion of sulfur trioxide in equilibrium mixture, but in a very short time. Reaction wants low temperature because it is exothermic, and if we decrease the temperature, the collision will be less. As per collision theory, reaction will go to the less extent. So there should be a compromise among them, and that compromise is that 400 to 450 degrees Celsius, and other compromise from the economic point of view also that I discussed with you. Now next point about the pressure. If you notice, there are 3 molecules of reactants and 2 only are to the right side. Whatever I discussed, that only is there, only just I am going fastly. By Le-Chatelier principle, if we increase the pressure, the system will respond in favoring the reaction which produces the fewer molecules, that will cause the pressure to fall again. Means if you increase pressure, then if you increase the pressure of the reactant, it will produce the product, but product has a less volume, so pressure will what? Decrease. In order to get as much sulfur trioxide as possible in the equilibrium mixture, we need to use high pressure as possible. High pressures also increase the rate of the reaction. However, the reaction is done at pressure close to atmospheric pressure, 1 to 2 atmospheric pressure, enough. It is also considerable high for that. Okay, now see the next point about economic consideration. Even at this relatively low pressure, there is 99.5 degree 99.5 99.9 sorry 99.5 percentage yield is there, considerable high yield is there. So why to waste that money in increasing the pressure? As like we decided, why to waste the money in decreasing the temperature? Likewise, because at that temperature also we are getting the good yield, then why to invest money? Likewise here, why to waste our money to increase the pressure if at room temp at regular pressure we get the proper yield? Conversion of sulfur dioxide into sulfur trioxide is not possible. A very small improvement that you could achieve by increasing the pressure is not worth to the expense proceeding to the high pressure. So it is not worth to spend that much. It is a conclusion. Yes, students, is that point clear? Economic consideration. Yes, now we have the last point now.
Yes, sir. Yes, sir.
Now, catalyst. Answer for my question. Which catalyst is used in the contact process? Yes, help me.
Vanadium pentoxide.
Yes, V2O5, vanadium pentoxide. The catalyst has no effect whatsoever on the position of the equilibrium. This catalyst doesn't affect the position of equilibrium, but it helps for the reaction. Adding catalyst doesn't produce any greater percentage of sulfur trioxide in the equilibrium mixture. Its only function is to speed up the reaction. Its role is to bring reactants to close each other effectively. In the absence of catalyst, the reaction is so slow that virtually reaction doesn't happen. Means it will take days and days to to attain the equilibrium. It is not sensible. The catalyst ensures that reaction is fast enough for the dynamic equilibrium to be set up with a very short time that the gases are actually in the reactor. So catalyst ensures that these reactants will combine efficiently or effectively to produce the product, that is what? SO3. In true sense, catalyst and equilibrium is different. Equilibrium is based on the reactant and the product. Catalyst is nothing to do there, only to speed up the reaction, only to give the provision for the reactants to combine. It is improving the equilibrium constant, or it is improving our reaction to attain the equilibrium constant. It's the role of the catalyst. Yes. So students, let us sum up what we discussed today. We discussed if we want to produce sulfuric acid, then what is the first step? What is the first step?
Sulfur dioxide production.
Yes, we have to produce sulfur dioxide. How it can be produced? Two reactions are there. One direct reaction and other by combination of oxygen with the pyrites. Second step. What's the second step?
Sulfur trioxide.
Yes, to get sulfur trioxide. And last step, from sulfur trioxide, we get H2SO4 via the oleum formation, or oleum after reacting with the water, we get the H2SO4. And during this course of reaction, whatever the conditions we are maintaining, about which we discuss. First, we can discuss about the pressure, which is 1 to 2 atmospheric pressure sufficient. Why it is so, that we discuss. Okay, one more point I forgot. Second, proportion of reactant. Reactants are in the 1:1 proportion, not 2:1 proportion. The reason we have discussed. Third point, the temperature that we use, it is the temperature, the small t that I use here, 400 to 450 degrees Celsius. The reason we have discussed. The fourth one, catalyst. What actually role of catalyst, that we have discussed. Here students, the topic of manufacture of sulfuric acid by contact process ends. Is that topic clear? Is that point clear?
Yes, sir.
Yes. Now if you have any question, any doubt, you are free to ask. Now I stop the presentation. Yes. Alia said no doubt. Ganesh, Kartika, Vaishnavi said no doubt. Yes. Yes, students. Now I am talking the additional information. We have to start our practicals. As per Rodriguez's consideration, experiments we have to start. Let we get the timetable. Immediately after that, we are going to begin. In case if college begins, then for experiment performing purpose, you may need to come to Kudal. Pratiksha, where are you? In Kudal? Nearby?
Sir, now I am in Pune.
Okay. Yet decision has not taken place. Let us see. But demo point of view, if anything is there, because today only principals might took a meeting and asked to take a experiments. So we will see. Till that it was planned that only YY is to what take. But let us see how the program runs. When it is there, then we can what in advance. I will inform to you. We can conduct the experiments. 2 days are sufficient for us to complete all experiments. Before that, if necessary, then demos for demonstration point of view, I will give you a few videos. Few videos of my friends are there. They have worked on those experimentation. So you can go through those demos so that you can come to know the experiment. So Pratiksha, now don't take tension. Still time is there to come to conclusion. Is it clear?
Yes, sir.
Yes. So we have to think about the experimentation. So about which alarm to your friends. So at that time they should what the remain present because of the important instruction. If they remain present, that's a better. If videos are recorded, then you can go through that. There's no problem. But we need to go through that. About our theory syllabus completion, analytical chemistry we have completed. Unit number 1 we have completed. Unit number 2, superconductivity portion left that you are going to study. Unit number 3 we have completed. Unit number 4, the group 16 elements now we have completed. Group 17 elements I will complete, and non-aqueous solvents you will study. So further only few lectures are there. Those will be needed to complete group 17 elements. So next week or this coming week only, by the end of this week, we can complete our syllabus. Then whatever topics I ask you to study, problems are there, we will use our lecture time for the discussion. Is the planning of the lecture distribution clear? Yes. Okay. Good. Okay, students, then I stop the recording and I declare here today's session is over.